Okay, so if you haven't already done it for potassium, do electron configuration, orbital notation shorthand, noble gas configuration. Did you do that already? While I was deleting things? Alright, so let's see. When you did your electron configuration notation, did you feel confident about that? Feel like you know what you're doing? How about shorthand? So, here's where I saw problems on the test. Two things, really. Number one, I had people come up and ask me like, well, I don't really know the names of them. Which one do I do what? So I might have given you a little hint. I guess that was a quiz. I won't give you a hint on the test. Like, you need to know the names of what you're doing. Then the biggest problem I saw on the test was right here. What to do with noble gas configuration. You may or may not have fallen into that category, but many of you actually did. So let's look at this really quickly. Just gonna have to write it out. I have to have this to show you. Does it look like that? And then 4S1. Okay, so look at your periodic table if you have trouble with this and find potassium. Move up a row. You with me, Victor? Okay. Find potassium. Move up a row. All the way over. Find the noble gas. Noble gas is argon, correct? So I'm going to go argon, goes in brackets. And then I know argon has 18 electrons. If I didn't know that, I could look at the periodic table and it would tell me that. So I take those 18 electrons and I'm going to work with my electron configuration notation and I'm going to get rid of 18 electrons in the order that they fill. So I go 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm going to look at what I'm left with, and that then goes outside my bracket. I saw all kinds of interesting made-up things on the quiz about how to do this. Now, do you have questions about what I just did? Because we're going to move on, and it gets a little trickier. Nothing? Good? Yes. Oh, I don't know. I don't even know. So let me ask you some questions. See how much you know. Let's talk about what we know about atoms. For sure, there's two things you should already know. All atoms on the periodic table are, what'd you say? Neutral. They're all neutral. See if you can do this one. Let me say it out loud. See if you can fill in that blank. In all atoms on the periodic table, the number of electrons, blank, the number of protons. Just fill it in, Lana? What do you say? Equals. All right. So we've talked about those things a bunch. We know that for sure. Now let's talk about some new stuff. Going to go against, or not really, I shouldn't say go against. It's going to change the way we look at some of these things. So these will be your new things. Atoms can gain So atoms can gain, lose, or share electrons in a chemical bond. 3 ways to bond. Gain, lose, share. The reason atoms bond and make compounds is to get a full outer shell. The goal of every atom on the periodic table is a full outer shell of electrons. So we can gain, we can lose, we can share. The reason we do that is to chemically bond so that we can get a full outer shell of electrons. A full outer shell equals 8 electrons. That's called the octet rule. Atoms will form chemical bonds to get a full outer shell, or an octet of electrons, 8 electrons in their outer shell. Really want you to think about this. On the periodic table, there are only two elements that don't want an octet of electrons. 2 elements that don't want 8 electrons in their outer shell. Think about it. When you know which 2 they are, stand up. I'm going to ask you another question for you people that are still sitting. See if this helps you. What atoms only use the first energy level on the periodic table? What atoms are those? Hydrogen and helium. Now, let's think about that. Don't sit down yet. Hydrogen and helium only use the first energy level. How many orbitals does it have? Good, 1. What is that orbital? S. S can hold how many electrons? 2. That's why. So these guys, H and He, You can sit down. I'm sorry. H and HE, how many do they want? Not 8. Somebody said it. I'm getting a lot of this. These guys want 2 electrons for a full outer shell. Those are the only 2 exceptions on the periodic table. There are a few that can hold more than 8. We're not going to focus on them right now. Think about this. This is 1s1, 1s2. Helium. Where's helium on the periodic table? Yeah, it's a noble gas. It's group what? All the way over here, group 18. What, do you know what's true about the noble gases and their outer shells? All 4. They all have either, helium has 2, everybody else has 8. That's why they're called the noble gases. They're like the kings and queens of the periodic table. They want nothing to do with all those other elements. Those other elements, they're like the peasants. And these are the kings and queens over here because they have full outer shells. All these peasants over here, they want to bond with each other so that they can get a full outer shell. Kings and queens, they don't want to bond with anyone. They're happy just the way they are. We really got serious about this. The peasants, they could actually revolt against the noble gases. They could do great harm because many of the peasants are radioactive and all of those kind of things. We can make a real children's story out of this. Anyhow, everybody wants 8 except for hydrogen and helium. This full outer shell is called noble gas configuration. Let's talk about getting a full outer shell. Gaining or give up electrons. We'll talk about that part first because it becomes important in our electron configuration notation, understanding how to do it and what it means. So think about this. Don't blurt anything out, but think about it. If I gain electrons or if I lose electrons, what happens to me if I'm an atom? If I gain electrons or I lose electrons, what happens to me if I'm an atom? What do you think? Maria, any idea? No? Oh, Lana? What? Atoms are supposed to stay neutral. If I give up my electrons or I get some extra electrons, am I neutral? No. What do I become? An atom with a charge. So when I gain or give up electrons, then I am an atom with a charge, and really now I'm called an ion. So an atom that has gained or lost electrons is an ion. The easier way to say it is an atom with a charge. If I have a charge, I know I either gave up something or I gained something. So let me ask you a question. If I move this, okay, you got this, okay. If I let's say I gain electrons. I really want you to think about this, because it's kind of like reverse of what you think in your brain. If I gain electrons, don't say the answer out loud, let everybody have some time to think about it. If I gain electrons, what happens to my charge? Obviously, I'm not neutral, but what kind of charge am I going to have if I gain electrons? Ava, what do you think? I'm going to have a negative charge. So if I gain electrons, I have a negative charge. And it's kind of weird when you think about it, because you're gaining something, you're adding something, but what you're adding is negative. So it makes you have a negative charge. We don't usually think of adding as a negative thing. I have a negative charge. And I'm called an anion. Remember that. A negative ion. Anion. A negative ion. So I give up electrons. I'm going to give them up. When I give up electrons, what happens to me? If I'm an atom, what do I become? You only have two choices. So think it through. I'm giving away some of my electrons. If I give away some of my electrons, let me ask you this question. Do I now have more protons than I do electrons? Yeah, so what would that make my charge? Positive. So this creates a positive ion. Negative ion, a negative ion. Positive ion, doesn't have a lovely name like that. But let me ask you a question. How many people in this room like cats? Well, that's good. How many of you are neutral about cats? Okay. Well, I have this really weird college professor who likes cats. He had this cat's picture on his desk. And this is what he told us to remember. This made me think he was kind of crazy, but anyhow. He said that cats were positive, and when they were positive, they purr. Remember, P goes with proton, which is positive. Cats are positive. This is called a cat ion, not a cation, a cat ion is how you say it. Cats are positive. So remember, a negative ion and a cat ion. No, it was just a big furry cat. Brownish, blackish. Nothing special. Just a cat. All right, so we've got anions, we've got cations. Let's look at what happens. Let's start with, I'm going to tell you something. I'm going to tell you this is neutral nitrogen. And when nitrogen forms an ion, it will be an anion. And it will equal N3 minus. That's the way I write it. Notice how I put the sign after the number? That's the correct way to write it. N3 minus. So when I look at that, I know it has a negative charge of 3, which tells me it gained 3 electrons. So the next thing I would think about is, and I should know, how many electrons does regular old nitrogen have? 7, thank you. How many does my ion or my anion nitrogen have? No! No! It's not going to be right just because you say it louder. What do you think, Olivia? What does this tell me? It gained electrons? Yes, it does. How many think? Yeah. Yay, 10 electrons. I have to add them to the 7 I already have. Now this is what I want you to do. It won't take you very long. I put nitrogen on purpose. I want you to do electron configuration notation for both of them, using the number of electrons that you have, and see what it looks like. It shouldn't take you very long, you don't have very many electrons. Now see if yours look like mine. Yes, do they? All right, so then I can say to you, when I look at this, my outer shell, right, doesn't go any higher than 2, so the second energy level has to be my outer shell. How many electrons do I have there? Okay, how many do I have there? In my outer shell. Count again. 5. Got 5 electrons here. Now let's look over here. I have my anion, nitrogen. How many electrons do I have? That is 8. It's 8. How many electrons do all atoms on the periodic table besides hydrogen and helium want? 8. This guy is now happy. He's with the nobility. He's got 8. He's got a noble gas configuration. That's what that would be called. So when I wrote it, well, never mind, we won't talk about that yet. Does that make sense? So I gain or lose to get 8 in my outer shell. Would this be an anion or a cation? What do you think? Do you agree with him? Okay. Let's look at another one. Let's look at, let me think for a minute. I don't want to give you too big a one. Let's look at sodium. How many electrons does sodium normally have? Okay, so we've got 11 electrons here. And I'm going to tell you it forms a cation, always. And it looks like this, Na+. Now, when I see that plus sign, what does that tell me? Did I lose or gain electrons? Good, I lost. Even with positive, I lost electrons. How many did I lose? 1. We don't want to write the 1 out in front. So here I only have 10 electrons. Now I want you to do noble gas configuration for both of them. See what happens. When you're done, check and see if they look like mine. Now I'm going to ask you a question. This is your opinion. What do you think people do most often in life if they have a choice? What's easier or what's harder? What's easier? Like, let's say you're at basketball practice and you have to do those things. They're called suicides, I think. You have to run and touch the line, and you gotta run back, and you gotta run a little farther and touch the line. How many of you basketball people, girls, every single time, you go all the way down and touch the line? Nah. You do what's easier, right? You kind of go, and you turn around. I do it. I've watched it. I've done it. So, what do you think an atom's going to do? If it has 2 electrons in its outer shell, is it easier to go find 6? Or easier just to give up a couple? Just to give them up. So they're going to do what's easy, just like you guys do at basketball practice. So when I look at these guys, here's my normal sodium. Did y'all end in 3s1? Is it easier to give this guy up to get an outer shell or to go find 7? Give it up. So what do I do when I form an ion? Give it up. I have 1 less electron. Do I have a full outer shell here? I have 8 electrons, right? Up here, I only have 1. I'm not happy with that. So, what I want you to do, one thing, I'm going to have you work with your lab partner. Let's take the following, let's work with these guys. I'm going to try and make them small ones. Magnesium, chlorine, aluminum, and we'll use oxygen. So I want you to use those, and I want you to, first, I want you to do electron configuration notation. Then I want you to predict gain or give up electrons. And then I want to know how many. I want you to name the ion type. And then I want you to write the ion with symbol and charge. So we've got 1, 2, 3, 4, 5 things to do with those. Write the ion symbol with charge, like, what did we just do? Like, I just gave you N, 3 minus, Na plus. That's what I mean by that. Okay? Questions about what you're supposed to do? All right, let's break into lab break to do it, and then we'll come back together.